Let's take a look and see how the township and range grid system plays out. In this case, in the Phoenix area, we're looking at part of the Phoenix topographic map. And what I wanted to show you was how the township and range overlays on top of our street grids. So we can see here the red lines are the congressional township lines, and that the numbers in there represent the number of a congressional township. So this would be a 1 mile square, so from McDowell to Thomas, from 19th Street to 7th Avenue. Now these 1 mile squares work very nicely in terms of trying to orient ourselves to give us distance and to give us direction. In this case, I wanted to use the example of Whittier School, which is located on 16th Street just north of McDowell. Now, if we can begin with, we can think of which direction is the school facing, the front of the school in this case. And in this case, it would be facing 16th Street, so the street would be facing east. So if I was working with the students in this class, I might ask them which direction are we facing within the class and try to base that answer on the street grid so that we can understand distance and direction. Now most homes in these major cities are also facing in cardinal directions. And so you could challenge your students to think in terms of which direction does their front of their house face. Using these as instances of orientation and of giving us direction, we can then begin to work on the students' spatial thinking skills. One simple question would be to start to chart once they can figure out which direction north is to figure out where does the sun rise and where does the sun set. Next, you could start building sort of a navigational or a cognitive navigational system with them in terms of like saying, using their directions, distance, directions, and orientations, how do they get to school? So you could start from leaving their front of their house. They could do a mental map and literally write it down of the orientation, the distances, and directions based on congressional townships. One thing that you can also do with students in class is, and let's turn back to the Whittier example, is to use the school grounds and to begin to help students to understand how distances relate to the time it takes from which to traverse those distances. So in this case, we're using the idea of the origin of the mile, which was originally developed to understand how far Roman soldiers would march, counting every time that their right foot would land. In a similar way, we can go out into the playground or onto the backyards of the school and measure out a 660-foot long distance measurement, which would be an eighth of a mile, and have students walk that in their normal pace and write down how long it takes them to traverse that distance. Using that, students can be able to do some math and figure out how long would it take them to walk a mile, and then you always add on a little bit of extra time, allowing for breaks and so forth. In terms of this topographic map, let's also begin to see that we could say, how far would it take students from Whittier to walk to Encanto Park? So literally from here to Encanto Park over here. Using as a relative system of understanding distance, the congressional township as well as the street grids. So if congressional townships are 1 mile and Whittier is in congressional township 33, we can begin seeing that 1 mile would go to 7th Street, 2 miles would go to 7th Avenue, and then 15th Street actually is representing a half a mile in between the congressional township of 31. So we got 2.5 miles. And then we could say we're a 1/4 mile up, so we can split this into quarters now. A quarter, 2 1/4, and then maybe another 0.7 to 0.4 of a mile, so 2.8 miles. If we go over and look at Google Maps, we'll see that it's actually roughly about a 2.9 mile walk.